Hello, everyone. Welcome to the second webinar of our series of MSPACE webinars. We'll wait 5 minutes before starting to give people time to join, and then I'll hand it over to our team to start the presentation. Thank you very much. Welcome again to those that are just joining us. We're giving another 3 minutes to wait for the people who has registered to join us. And then I'll pass it over to our team to start the presentation. I see there are a few more people joining us. Just let's give them a couple of minutes. Okay, welcome everyone again. I'm very proud to leave you with the MSPACE team to present the second of our series or MSPACE webinars as we are closing our project. So without further ado, I'll leave you with Anna Quiros and Benjamin O'Driscoll and the rest of our team to present this exciting bit of the project as the rest of it. Anna, all yours.
Thank you, Luz. Good afternoon, everyone. Thank you for joining the ASPACE webinar. We'll be talking about this new software that we're very excited to launch today called Assisted Spatial Prioritization Addressing Climate Effects. We'll give you a little overview of what the tool is after I think some of you have come across it in the previous months. So it's something that we've been working on for the last 4 years. So we'll give you a little introduction about what it is, why and who is it for. So if you're here, hopefully you're interested, but we think it has quite a lot of potential to address spatial management in general. And so we'll talk about what it does, And then I'll pass you over to Ben, who's going to give you an overview of example workflows that you can do with the tool. And then I will show you some of the examples that we prepared for you just to show you how we think it could be useful, and then a little bit about what's in the pipeline as well coming later this year. And then at the end, if you don't mind, please save your questions for the Q&A session. So we'll have about 20 minutes. And if you would like to raise a question, please use your Q&A option in your dashboards on Teams. Thank you. So without further ado, let's get into what is ASPACE. So ASPACE is already publicly available. So if you follow that QR code with your phone, it will take you to our webpage. And ASPACE is about enabling a climate resilient future for the ocean. Specifically, it's a software, a spatial prioritization software called Assisted Spatial Prioritization Addressing Climate Effects, which is conceived to support the design and exploration of climate resilient, socially acceptable, and economically viable spatial management scenarios. ASPACE has been designed as a co-creation process with end users, particularly in the policy community, but also in the marine industries and the private sector. And it is designed with a view to support stakeholder engagement, evidence-based decision-making, and research into spatial management, particularly considering climate resilient approaches. The outputs of the software that we'll show you today are spatial management scenarios, as well as a number of metrics that allow you to compare different alternatives. So ASPACE is designed, and hopefully it's ideal to support and enable evidence-based and climate-smart decisions around marine sectors, marine planning, and sustainable ocean planning in general. So why did we create ASPACE, and who is it for? Well, you know about ocean climate change, and in our decision support toolkit, as people that are interested in spatial management questions, it is a bit of a gap still at the moment. So even though some tools enabling spatial management do include some elements of climate change, they're not very comprehensive. And so climate change in the ocean is, of course, changes in temperature, but that is not just long-term changes. It's also changes in seasonal patterns. It's about increased frequency of extreme events like heat waves, as well as leading to changes in circulation, stratification, as well as sea level rise. And this in itself is linked to biogeochemical change in the ocean. So that's long-term deoxygenation or losses of oxygen, as well as seasonal oxygen deficiency, which has particular impacts in the coastal ocean. It's ocean acidification, as well as changes in natural carbon flows and sequestration. And these effects in turn affect our marine food webs, which leads to changes in species composition, as well as ocean productivity. And so when we talk about human uses in the marine environment, this has direct bearing, of course, on the conservation and restoration of wild ecosystems through biodiversity change, through loss of historically abundant species and new species arrival. But it, of course, leads to a loss of efficacy or changed efficacy in our interventions to protect the ocean. Thinking more broadly about human activity, what this might mean is a loss of catch, a loss of harvest for aquaculture, but also changes in multisectoral interactions between these sectors that are very directly linked to species and habitats, as well as all the other uses that we have for the marine environment. And this in turn leads to risks to people and infrastructure. So it's no surprise that climate smart ocean management, or ocean management that addresses the causes and impacts of climate change, has been sought for by the international scientific community for years. And indeed, the latest IPCC IPBES report identified that climate change makes preservation-oriented objectives near impossible, which means that practitioners, particularly those managing ocean space, are faced with the challenge of facilitating biodiversity change to promote adaptation, not just for nature, but also for people. And it's not just the scientific community. So, for example, the high-level panel for a sustainable ocean economy, which is a number of governments from around the world, have also said that there is an immediate need to reduce risks to the blue economy and finance. For example, in their report on sustainable ocean management, they claim that reducing climate change impacts on economic development is needed to lower risks to property and infrastructure, as also to enable greater economic opportunity through adaptation. And in their recent guide for ocean finance for a sustainable ocean economy, they also highlighted that this requires a significant shift in how we address risks and how they can be minimized and shared to ensure effective, sustainable resource management for the ocean, to build resilience in advance of significant climate change events, so extreme climate change, as well as to reduce the impacts of hazards in the long term. So it's not something that is just called for by the scientific community, something that we as people that are involved in the management of the ocean and investing in the ocean are interested in. So ASPACE has been built with and for people whose decisions shape the future of the ocean. In particular, thinking about nature investors, so those investing in nature positive outcomes, our marine industries, and those interested in growing a sustainable ocean economy, those involved in conservation and policy design, which might be interested in which ecosystems need protection now versus later, as well, of course, as our ocean-based communities whose livelihoods are directly dependent on a climate-resilient ocean. And so the main question, the top line that ASPACE wants to address, if you are in one of these communities and perhaps more than one of those, is how do I de-risk my activity from climate change in a way that maximizes economic returns for my region with a view to increase the probability of my activity receiving social license. And so if we, again, it's about addressing climate change as a holistic process that affects nature and species and habitats, but also humans. And so the way we start in ASPACE is by thinking, for example, if you are, for example, developing wind or managing the development of the renewable sector and you want to reduce impacts on nature, for example, thinking about a fulmar or another seabird, you might think about key habitat changes that climate change will bring for the species, for example, summer fronts and marine heat waves, which affect not just foraging areas for seabirds and other megafauna, as well as the viability of their colonies, but you also need to think about what are the prey species that such megafauna will require to be able to exist into the future. And as you can see, all of these considerations have different spatial patterns if you think about their change over time, which is difficult to make spatial decisions on. And then, of course, you need to match that to where you have wind resource and the possibility to grow the wind sector. Or, for example, if you're someone in an activity linked to demersal fisheries, or you're managing demersal fisheries, you will perceive climate change and you will need to think about climate change from the perspective of the resource. So how are those species responding to climate change? How are they shifting the distributions, and how does that interact with other human activities and other initiatives that occupy marine space? And of course, all of these spatial patterns are difficult to act on, but they also change over time. So just thinking about one particular species, you can see that that spatial pattern is not the same as we think about the future. And so it's to make these informed climate smart decisions, we need to think about not just spatial patterns, but also as climate change as something that is progressing over time. So with this in mind, what does ASPACE do? Well, first and foremost, it creates climate data products that are geared towards use in spatial decision making. So if you were thinking about all of those spatial patterns and temporal patterns, what ASPACE does is deploy a particular peer-reviewed scientific methodology, which condenses those complex climate change time series and those multiple spatial patterns into a three-way spatial classification of the ocean. And what that allows us to do is to simplify those spatial patterns with a view to where they are most impactful for the particular habitat components or species groups or marine sectors that you are wanting to manage spatially. And in addition to that, it estimates the climate resilience of both the current distribution of that particular species or habitat or activity, as well as where are the areas of opportunity in the future, considering that climate resilience pattern. So it's a tool that, to begin with, is well suited for uptake in spatial decision-making chains, where you're often considering multiple layers of spatial evidence together. But of course, that's not all that we need to make climate smart decisions about marine space. And in fact, if you ask practitioners, and in fact we did, and what they want to know is more than that. They need to know about the the ecological impacts of climate change, but they also need to know about the economic and social impacts of those decisions linked to climate change adaptation. They want to enable climate change adaptation, but they also want to know about this from the context of other sectors, where to place new technology, where to promote adaptation, where to grow renewables, and so on and so forth. So there is a lot more in the social and economic domain that is necessary to enable those climate smart decisions. So what ASPACE does is take that evidence forward and look at the economic impacts of spatial decisions beyond what we have at the moment, which we would refer to as the business as usual. So using a particular type of macroeconomic modeling approach called input-output modeling, and you can find the source for that, for what's behind ASPACE in those references. It looks at the relationships between different marine economy sectors in a region of interest, how they relate to each other in terms of activity, but also what is their output in terms of employment, greenhouse gas emissions, and other variables. And so that a change in one sector, for example, by restricting or prioritizing a particular sector in an area, will have downstream impacts, not just on that sector, but on all of the other sectors of the marine economy that it's linked to through indirect effects. And what that allows us to do in ASPACE is then to look at different types of scenarios, just for example, here, the baseline and the business as usual. And you can look at how change in activity of one sector might cause changes, for example, in wages in your region of interest, or indeed in the gross value added of your economy. And that allows us, in essence, to translate those decisions about marine space also into economic metrics. And beyond that, in terms of increasing social license or exploring potential social license of different types of decisions, what ASPACE also has is a component that looks at the values that people hold about marine space. So in particular, using methods as referenced there at the bottom, developed by our colleagues at the University of Essex, it's about understanding and consulting our end users. So, for example, very geared towards focus groups with stakeholders around particular policy decisions or investment decisions, and trying to understand how they vary their values about marine space. For example, looking at things like food provision, job security, climate change, biodiversity, and so on. And once we have a view of that, then we can also score different scenarios based on how they align with what people value. So in essence, what you end up with for different scenarios in ASPACE, you end up with a number of metrics that tell you how much your particular spatial decision addresses climate change by looking at things like the area of climate change refugia, or areas that are climate resilient that are used, and the greenhouse gas emissions of your region, and how that relates in your scenario, which in ASPACE are called alternative spatial management scenarios, how they relate to the business as usual, which is the current status if we do nothing, so just climate change impacts. But for every decision you explore, you can also look at economic metrics like gross value added, labor compensation, number of jobs, as well as how that particular scenario aligns with how people value marine space, as well as how that relates to the business as usual. And so what ASPACE does is it makes climate change evidence tangible in stakeholder consultations, which means that there is potentially the potential to improve buy-in or social license for particular spatial decisions. But what it does is supports decision makers in a multi-objective setting, for example, thinking particularly about marine planners. And what that means is that it enables or improves the ability of decision makers to make evidence-based trade-offs between alternative spatial management scenarios, particularly in the context of climate change adaptation. And with this, what we hope to do is to meet the needs of those various types of spatial decision makers with a view to increase climate resilience for ocean life and ecosystems, to reduce the risks for ocean investment, to reduce risk for ocean-based livelihoods, to increase economic resilience and growth of the blue economy, and indeed, and more widely, to enable sustainable ocean planning that is future-proofed, because it's climate resilient, integrative, inclusive, place, ecosystem, and knowledge-based, as well as enabling the blue economy. So I'll pass the word now to Ben, who will guide you through some of the key workflows in this space.
Okay, so hello everybody. My name is Ben O'Driscoll, and I'm a research software engineer here at PML. really excited today to showcase the ASPACE tool. Myself and Mohammed have been working on this for a long time, so it's really nice to see it here at the launch event. So what I've done in this next section is create a section of video recordings that will demonstrate lots of the salient workflows that you'll use as part of this tool. So I'll refer you to the user guide, which is now online, which will provide much more detail than what I can do in these screen recordings. But I'm really hopeful that they'll give you a really nice starter for 10 to get you using the tool. I want to start with this diagram here, which gives you an overview of all of the phases that you'll conduct as part of using this tool, and the video recordings will very much touch on each one of these phases. I think the other thing just to note before I get started is that the platform is already really rich in data, so there's lots in there for you to get started with. But I really encourage you all to look at the user guide and how to upload your own data, because I appreciate that's really where it becomes valuable. So yes, really excited to be here, and if you're happy, we'll get started. Okay, so hopefully some of you have been able to navigate to the home page where you see our really snazzy front page. And this assumes that you're logged in, but if you're not, you would go into a sign-in page here, which would bring you to your overview dashboard. And I just give you a quick overview here, but it essentially links you to the key areas across the platform. The navigation is also replicated on the left-hand side on the side panel. So I bring attention to the important documents in the bottom left-hand card, which gives you a link to the user guide, terms and conditions, and privacy policy. So really, when it comes to using the tool, I really encourage you to look through the user guide. There's a really helpful section in there called Quick Start Guide, which will show you everything we're going to talk about today and much, much more. But certainly, there are other routes to get support if you need some. So the first place would be the FAQs. And in here, you can look at some questions that are quite commonly found. And then also, if you're still stuck, then don't hesitate to reach out to us. And you can do that by this ticketing system here. So provide as much detail as you wish, and we'll pick it up on our end and provide you with some solutions to your queries. Great. So let's go and create a new project. So you can see that we can link to it directly in our dashboard or look in the side panel. And we open our My Projects page, and we can go to add a new project. And I'll just pause it here very briefly. You can see these green areas here represent the data that's already uploaded into the tool. And you can see we've already got a lot in there, which is great. But absolutely, this tool has been designed for you to bring your own data sets. So again, forward you or signpost you to the user guide on exactly how to do that, because it's outside of the scope of this launch event today. But it's there for you to bring your own data. But let's just assume you want to explore a particular region of interest. You draw your bounding box, and it will bring up the models that are available for that particular region to select on the model of your choice. And then there could be multiple scenarios for each one. We're going to select RCP 4.5 here. And then we have the option of deciding how we look at the trends available for each variable. So we look here at the ecosystem service tool. This is a really nice tool that enables you to bring forward defaults associated with each one of these ecosystem types. So you can see that the variables are provided for you as defaults. If we take a step back, we can look at those variables and trends directly and edit them using the drop-down button. The drop-downs on the screen, and you can see that the user is really given that flexibility to edit them if it's appropriate to do so. So once that's done, we give our project a name of interest and a description that means something to us. And I just pause it here very briefly. But this is important to know that the tool is very flexible in terms of what you'd like it to do. So some people might be really interested in what the climate resilience does for very short-term targets, maybe next 20 years. Others might be more interested in looking at the end of century. So this option here allows the user to customize that output. I think in this example, I go to the end of century. So I select the bottom time slice and we create our project. And you can see it appears in our project list here. And then we're able to access the activities. We can see our scenario here, 4.5. But it's not yet started. The meta-analysis stage hasn't been conducted. So this is when we go to execute that and we click on the execute button. We fill in our password and hit the execute button. So at this point, the analysis can take between 30 minutes to 60 minutes, depending on the size of the job and also the existing queue. So at this point, feel free to put the kettle on or even close down the browser, shut down your PC, because you'll receive an email when the meta-analysis is complete. Great. So once we've run our meta-analysis, next obvious step would be to visualize some of the outputs. So to do that, we would navigate to the project we created, go to the activities, and in true Blue Peter style, here's one I created earlier. And we're going to go to the view outputs, and we get this map seen on screen now. So we can look through the statistics and how those statistics vary in time and also across the variables. So this really gets the user to have a look at that information if that's appropriate for your needs. So here I'm looking at hedges G, but I might be interested in tau squared, which is akin to uncertainty in these calculations. So the summary M files then is one method of condensing that information into a single value, but we have it for several timestamps, which we can choose to look at. And then finally, we look at the high agreement file, which looks at condensing those files into one value based on temporal alignment, so how it changes across time. So at this point, we might be interested in starting to share this information because it gives us information as to the climate resilience. So we have areas of, I'll just pause it here. We have areas of hotspots and areas of refugia. So at this point, we might want to start exporting this data to show to our colleagues and stakeholders. So we can do that, and we can start changing the base map. It's more appropriate to have different backgrounds. We can do that by clicking on the base layer button. And then it might be appropriate to start looking at some of the GIS layers to overlay onto this data set. Now I'm showing the data that's already loaded into the ASPACE tool, but again, I just encourage you all to bring your own GIS layers and upload them into the tool for your own specific needs. So in this example, we look at a modified version of the Northern Ireland planning area, just to give you a flavour of what this can do. And I show here that we can change the colour again if it's necessary. You can imagine this would be powerful if you have multiple layers to overlay at the same time. Okay, great. So once we visualized our meta-analysis, this is when ASPACE really comes into its own in terms of giving us the option to create alternative scenarios. So I'm going to shorten ASMS to alternative scenarios. And we're going to look at exactly how we would go about creating them. So we would go to navigate to our projects page and find our scenario that we've created. Click on the optimization button. And here we've got the option of creating an alternative scenarios. Oh, sorry, just pause it there. We had two options, add in basic mode and in advanced mode. I just wanted to pause it here because let me just take it back a little bit. There you go. So the drop down open. So you've got two different modes here. I think it's important to say, so the basic mode provides you with lots of default filtering for the constraining files, which is really useful to get you started. But as you get more specific questions you want to answer, you'd want to migrate to the advanced mode because it really gives you a wide flexibility into how to create these alternative scenarios. Lots more details provided in the user guide, but for the sake of today's launch, we're going to just run through a basic mode creation. So we select our basic mode, and this launches the wizard. So this page changes based on the selections that you make, and you work top to bottom. So it should be hopefully a very obvious way to maneuver through this. So in this scenario, we actually select the planning objective is creating climate resilience of existing areas. And this is where we're looking at overlaps of our marine sectors with climate resilient areas. So you can see that the interface changes as we add things and select things. And here, I will pause it now to show you that these two boxes relate to coastal distance, that being you can provide an additional constraint so that if your activity is limited to within a certain number of meters away from the coast, you can constrain the output with that. And also you can constrain it with a limitation on depth. Leaving these inputs blank removes that constraint completely and just provides you with all of the available areas. Okay, so moving on, once you've input those, we look to step 2, and this is where we start loading in our layers of interest. Again, I'll just reiterate that we have selected some layers that have already been preloaded, but all of these layers would be available for you to upload yourself. So in this example, we select our MPA network in Northern Ireland, and you can see here that we've got some filtering already preloaded into us. So this is the advantage of using the basic mode, is that we have this information already included. But you can understand that as you progress with the analysis you would like to conduct, you'll want to customize these filters to your exact needs. So moving on, we would like to encourage, provide additional GIS layers. And in this video recording, I've provided you with the layers that are appropriate in order to bring out the additional economic modeling and social alignment scoring. So these are some richer information that can be provided. So for the sake of this example, I've selected on this marine plan area in Northern Ireland, but then it's also applicable to the UK and other areas. Great. So you can add as many additional layers as you choose to before you finalize your ASMS creation in step 3 by providing a name and a description that is appropriate for your needs. Great. So once you've created your job, you will have to execute it in exactly the same way as what you've done previously for the meta-analysis. And it just reminds the user that these jobs, they do take some number crunching. So this is the reason to have the password there. It's just a gentle reminder that to understand the consequences. But it's for the ASMS creation point of view, these take much less time to process. So once you've entered your password, it's likely that your job will be completed anywhere between 5 and 20 minutes, depending on the size of the GIS layers and the existing queue. But again, submit your password and execute, go put the kettle on and come back when we've sent you a confirmation email that your job has been completed. Great. So we've just created our alternative scenario. Now it would be really great to actually visualize this thing and see what it comes up with. So to do that, again, we navigate to our project of interest and we go to our activities. And we'll find a list of our alternative scenarios. These are ones that we've prepared earlier. And we hit the view output button. So this launches a map where if we select the optimization, we'll be provided with a list of completed alternative scenarios to choose from. And once we select this, we can remind ourselves that this is the refugia hotspots and bright spots indicated by purple, green, and pink respectively. And these are the so the green areas here and pink if we had any, but we don't in this example. These are areas where we have climate resilience. And for this particular example, we want to overlay marine protected areas and see where there is an intersection between existing marine protected networks and climate resilient areas. That will then give us our regions where we have climate resilient networks. So here I've overlaid the MPA network, and hopefully you can convince yourself when we change this to the ASMS region, you'll be convinced that the areas in this lovely mustard yellow are the regions where we have this overlap between existing marine protected areas and our climate resilient areas. So it's really nice to see that as a useful case study coming through. Excellent. So finally, once we have multiple alternative scenarios, we might think it's a useful thing to compare them. So let's have a go at doing that within the tool. Again, we navigate to our project and our activities, then our specific scenario, and we'll find our list of existing alternative scenarios. So here, oops, sorry, let me jump back. So on this page, we're able to hit the download button, and this will download information to your machine. You'll be provided with shape files of the regions of interest, but also some statistical data which relates to any of the economic outputs and the social alignment scoring. But the tool allows you to make those comparisons within it. So another way to look at that information is to hit the compare results button, select the alternative scenarios that you're interested in, hit the compare selected, and then it brings out this lovely table which provides you with all of the information that you need to help make informed decisions. So any rows that you might want to provide more information on, you can hover over and you're provided with more information. But again, I point you in the direction of the user manual on exactly what each of these rows relates to. And Anna's going to talk more in the next section exactly what's going on here. So that's a very quick overview of some of the workflows that you might complete in the tool. I would encourage you, any questions, fire them up in the Q&A, but I'll pass you back over to Anna, and thanks for listening.
Thanks, Sven. That was a great overview. So what I'll try to contextualize what's been presented with some more specific questions that might be of interest to our end users. So Ben has already showed you that example where we were looking at the climate change sensitivity of benthic habitats. And one of the things that the tool can do is look at the current climate resilience of your sector or your habitat based on where things are now. And so in this particular example, we're looking at a specific emissions scenario, so moderate emissions. We're looking at a particular time period, so the immediate future, and we're just looking at this box, which is our region of interest. And so in this particular example, the purple are the refuge areas and how they relate to the marine protected area network, which is the blue, and the red are the current wind leases around the UK. So a particular question you might want to make is the question that Ben referred to. So for example, where are the benthic habitats resilient within the current MPA network? And this would be a particular interest for people that are managing MPAs, but you can think about it in the same way if you had, for example, if you were thinking about aquaculture facilities, or you're thinking about fisheries, or about how your sector might interact with those sectors. And so in this particular case, you see that the mustard color gives you where the benthic habitats are resilient within the current MPA network. But another question might be more to do, with those multiple sector interactions where you might want to look at areas of opportunity or priority areas. And in this case, for example, thinking about expansion of renewables, but again, it could be expansion of any other sector of ocean-based solutions for climate change, again, aquaculture, wind. And so in this particular case, we're looking at compensatory measures. So if you have a region where you're interested in prioritizing a particular sector, in this example, it's wind, then where could you create compensatory measures for nature? Because you might need to build in areas which are currently important for nature. And so in this case, the yellow areas give you areas adjoining the current MPA network, where you also have climate resilient benthic habitats. And in this particular example, ASPACE is avoiding all the new wind licenses. And so, for example, it's a good example you can extrapolate for other sectors, but it gives you that view of what the tool can do, both considering the climate change analysis as well as multi-sectoral interactions. And so what we can do then is, in this particular case, we might want to ask ASPACE to find those adjacent areas to the MPA network where it could put compensatory measures, but you might want to give it different targets. So for example, you might want to ask it, okay, find me these areas to a total of, for example, additional 4% of our current MPA network distribution, or 20% or 30%. And so using that feature that allows you to compare the multiple alternative spatial management scenarios. So here, each of these columns to the left is one scenario. And what you can see is that the desired questions, so for example, the 4%, 20% or 30% additional area for nature, and whether the tool has been able to meet that. So has it found a solution that met the criteria, in this case, climate resilient habitat for benthic habitats and avoiding wind leases in areas adjacent to the MPA network. And in the first example, where we were seeking a 4% increase, it could. So you find a yes. And in the other ones, which had more ambitious targets of 20 and 30%, it couldn't in this particular scenario and time frame. And so then you get a number of other metrics associated with that, how climate resilient that scenario is. So how much additional kilometers the tool was able to find in that particular optimization pathway, and what was needed. So you can see that in the case where we wanted a 4% increase, we needed 17,000 square kilometers extra for nature, and the tool could find that. But in other cases, on the 20% and the 30%, the number was much larger. So we needed, for example, 85,000 square kilometers to increase the MPA network by 20%, but it could only find 19,000. So it couldn't find that solution. And then it also looks at things like the total greenhouse gas emissions in your scenario, as it compares to the business as usual, and what the change is. And these are outputs associated with the economic model and the particular activity of different marine sectors, given this change you've imposed in spatial uses with your alternative spatial management scenario. And so beyond that, what you can then also look at is the economic outputs in truth of the model. So you can look at potential changes in wages between scenarios. You can look at potential changes in the number of people employed in the region, the gross value added of the whole economy, the gross value added value of the economy. So you can see that in this particular case, because the area used in the scenarios, or the area optimized, is actually quite similar, it varies around 4 and 5%. So then the scenarios actually look very similar. But of course, if you impose more bigger changes in marine activity, then those changes between scenarios are going to be exacerbated. And you can see for each of these variables how they relate to the business as usual. Again, the business as usual is the centering point for the comparison. So the business as usual being what we have now, and then the ASMS line gives you the value for each of those variables for each of your possibilities in the different scenarios you've created within the same project. And in addition to that, it looks at, as we mentioned, how people value marine space. And of course, this is very linked to whatever stakeholders you've spoken to. And so, you can change that data depending on how you work with different focus groups, or you can look at the different values matrices that are already in the tool. And so you can see that for the business as usual, the value is 0 because it's the center. And then if the output of the scenario is positive, that means that the scenario is more aligned with how end users perceive marine space. And if it's negative, then it's less aligned. And again, here in these scenarios, the value is similar because the area optimized, or the area that changed in between the scenarios, is more or less the same. So 45% of the area of the MPA network. But again, if those changes were different, then you might see bigger changes in this row. Okay, so that's the tool as it is, and it's already available. So you can go, if you're interested, go to the website and start playing with it. But of course, we are already have more developments in the pipeline. And I just wanted to emphasize that ASPACE is web-based and free to use, so you can go ahead and play today. There's no payments involved. The version 2 is already in development and scheduled for the winter, so later this year. And with it, it will have an expanded economic model that has a better representation of the wind sector. Again, if you refer back to the user guide that Ben mentioned, you can see the description of the current economic model, and this is what's coming. We are going to have expanded data sets for Europe and some additional global data sets, and that's from ongoing research programs around Europe and legacy data. And in future, the users will also be able to upload their own economic data so that they can run the economic model features in different areas than currently are hosted on the ASPACE tool. And they will also be able to upload other end user values for the end value matrix. And that means that if you work with different groups of end users in different regions or across different sectors, you can rank your scenarios in a way that's more tailored to that particular decision-making context. And we will also be doing some changes to the multi-sectoral scenario optimization. So that's in the generation of alternative spatial management scenarios. So you have more flexibility in the way that you do those multi-sectoral scenario optimizations. At the moment, the tool we have already secured funding to 2030 to continue further development. And of course, if you're interested in any of these features or you want to propose new features, please approach us and we're very happy to chat to you. And so today on the call, we have most of the team. And so you can see that the core team of ASPACE has quite a variety of expertise, from economic modeling to climate smart ocean management, to government, stakeholder preferences, sustainability, habitats, marine planning, and of course, our lovely software developers. So we are here to ask any questions. And just a very big thank you to the MSPACE, Marine Spatial Planning Addressing Climate Effects, which was sort of the birthplace of ASPACE. So a big thank you to all the community that interacted with us and helped us develop the concept of ASPACE over the last 4 years, and to our funders, NERC and the SRC, but of course also to the European Commission for funding of subsequent European projects, Insight and AXA, who have allowed us to continue the development. So if you're still interested, please stick around for the Q&A, and we're here and very happy to chat to you. Thank you. So I don't know if there's any questions. Go ahead, Hank, go ahead. I don't know if Hank can hear us. You can go ahead and ask your question if you like. I don't know if you have to unmute Hank, Luz. Everyone is muted. Luz, can you help?
Hello? Hello? Can you hear me?
Yes. Yes.
Oh, great. Thanks for that. Yes. Thanks for a great talk, for a great overview of ASPACE. I've got a much better idea of it now. I was typing out a question, but I think it'd be easier just to speak instead. I'm interested in, as you know, with the Value of Marine Artificial Structures project, I'm interested in whether ASPACE, if we knew about the environmental value of the biodiversity that grows on wind turbines, but also oil and gas structures. So if we knew about the biological value that grows on those structures currently as they stand, will ASPACE be able to incorporate that value? And if we had the right spatial layers of knowing where all those structures are going to be, could ASPACE then project that value, map it out, and then look at potential climate resilience over time, and give us all an idea of the ecological, social, economic potential that we already have growing on our structures, as currently as biofouling is how we think of it. But if we had an idea of that going forward, I think it could be really useful for decision making. It could be useful for considering compensation measures, and how we can build more nature positive, nature inclusive thinking into our development. Well, as well as helping us think about decommissioning as well. I'm wondering, will ASPACE be able to shed some light in that area?
Can I ask, Henk, do you mean economic value or just biodiversity?
Biodiversity initially, but as we know, I'm thinking about a spillover effect where you get a reef effect around large structures, and you might actually get enhanced production around those structures. You could actually get more fish, for example, that could spill over, and then that might actually increase economic activity, fishing activity around the structures.
Okay, so I think there's two ways. One of them is if you had mapped all the biodiversity in all of the structures, then we could use that just as a layer, like we would treat any habitat layer or species distribution layer. So it could be treated that way in the scenarios, and then yes, we could play with it that way. Or I think what you mean in the later part of your question, you're talking more about modeling potential effects in terms of spillover and so on. I mean, that would require a different type of data. That would require, some modeling that had considered that effect and created that projection. And in that case, then we could also ingest, ASPACE could also use that as the modeling time series that would be the core of that project. So it could be treated in that way. In the first instance, it's just about having the correct data sets. Yeah.
Yeah. Great. It sounds like we need to invest in creating those data sets initially, but then ASPACE might be able to bring that all together, and we can start asking those sorts of questions.
Yeah. Thank you. Thanks. That's an excellent question.
Great. Thank you.
I don't know if there's any other questions in the Q&A, or if Luz can help us. I mean, if this is the time to ask. So if you're interested, please just raise your hand or use the Q&A feature. You muted, Luz.
Sorry, I don't see any questions, but everyone has their mic and camera open if they would like to raise their questions.
And there's obviously no right or wrong questions. And if not, then I mean, we're very happy to give you your lunch break back. So we'll give it another few seconds. And if there's no questions, then we will close it. Yeah. Okay. Well, thanks very much for coming, and by all means use the QR code and get in touch with the team that way. Thanks for taking the time to speak to us, and we look forward to hearing from you in the future. Thanks very much.
Thank you. Bye.
Thank you.
Thank you.